Greetings and welcome to another special installment of Slant Alpha Adventures. In our most recent tutorial, we talked about US IFR route planning. In this edition, we're going to discuss VFR route planning, and again, I'm focusing on the US because it's what I'm familiar with, but also because fully detailed VFR sectional charts are freely available on the web via SkyVector.com, which is what we're looking at right here. Now, IFR route planning is more or less about coming up with a series of connected line segments like we did in the flight that we put in the other tutorial. This is from Raleigh-Durham in North Carolina to Norfolk in Virginia. And then you figure out how to make your plane follow those line segments as precisely as possible. Now, in my personal opinion, VFR planning is less about creating and following a route and more about knowing the airspace that's around you and the airspace that's around where you want to go. Adherence to a strict, precise route isn't as important as knowing, for example, what airspace you need to avoid, what airspace you should avoid, what airspace you should be aware of, and what airspace you need to be talking to somebody to operate in. Now, the snips that I just showed you are some, but not all of the examples. One thing to point out really quickly is to remember that we're talking about flying on VATSIM. Restricted airspace on VATSIM is very, very rarely active if you were to ask ATC about the status. And if there's no controller covering the area at the time, it's pretty much fine to wander on in there if you want to. However, I always try to plan VFR flights to avoid restricted airspace as though it's active and closed all the time, mainly just for the added challenge. And remember, I'm a simulator pilot only, but I presume this is not a bad idea in the real world too. Let's come back over to SkyVector and we'll switch over to the VFR charts. And let's blank out our route from the last tutorial. For the first GA Wings event that we're putting together, leg number 2 is planned to be a VFR flight from Norfolk International, KORF, to Ocean City Municipal in Maryland, KOXB. So there you see SkyVector's plotted a nice direct path from one to the other. Basically right up the coast on a 040 heading out of Norfolk. And that'd be great. That'd be nice and easy too, with that nice coastline to follow right up the Atlantic coast. But here's the problem. We get this nice big restricted chunk of airspace right here near Wallops Island Flight Facility, which is a military testing area where they launch rockets and stuff like that. You don't really want to be flying through there. And if you look to the west, well, guess what? We've got another restricted airspace. This one's associated with Patuxent Naval Air Station right there in southern Maryland. So we're left with this little tightrope walk here right up the middle, and we need to figure out a way to stay out of both of these and split the uprights here. Well, we've got a few options. Broadly speaking, I guess I'd say we've got 3 primary options. First one is, if you've got a GPS, look at this. We've got these 2 points right here, and I believe they're put in here for this sole purpose, actually. I would imagine. And VP, points that start with VP are usually called visual points or visual reporting points. So most likely these exist for the sole purpose of navigating right up through this corridor between these 2 restricted airspaces. Let's get that out of the way and we'll see what this looks like. What is this called? VPINN and then VPETS. Probably stands for something that I'm not aware of. Visual point, something, something there. Anyway, so this gives you a nice, if you're going to put this in your GPS, gives you a nice path straight up off of Norfolk, right up the Delmarva Peninsula, and yep, guess what? You stay nice and west of the Wallops Island restricted airspace, but well east of the other space here that heads over towards Patuxent. And then direct from VPETS, if you follow this 062 heading, you're straight into your destination of Ocean City Municipal. And if you wanted to fly this with your FSX default GPS, it actually wouldn't be that hard to put in just a route with the origin of KORF, the destination of KOXB, and then these 2 points, VPIN and VPETS, and you can use SimBrief to export that into a format that you can load right into your default GPS. You can refer back to the tutorial we did on IFR navigation on VATSIM if you need a little guidance on how that's done. So that's one way. Let's go ahead and blank that out. And let's look at the second method. Did we get rid of those? Yeah, that we did. Okay. The other way is if you don't want to use a GPS, and I tend to do things with radio navigation and pretend that the GPS in my beach barren isn't there, but we've got some radio nav-aids in the area. We've got this Cape Charles VOR, and if we go further on up, we've got this Snow Hill VOR we can use as well. Let's just kind of plot these in. CCV, Charlie Charlie Victor, and Snow Hill is Sierra Whiskey Lima right there. Wow. Okay. So if we were to depart Norfolk, go direct to Cape Charles, and then from there we kind of follow this, what is it, 041 off of Cape Charles and head direct to Snow Hill, you can see that we kind of graze this this Wallops Island airspace, not only the delta around the airport itself, but the restricted airspace too. We can kind of encroach on this this edge of it. We could, in theory, put a radial into our navigation radio of 041, either outbound from Cape Charles or inbound to Snow Hill, and then deliberately fly left of it to make sure we were staying off of that borderline there. The path roughly approximates that western border of that airspace, but then the catch is not to fly too far west of it and end up over here in this airspace by accident. Another cool little trick you can do with SkyVector instead, let's take Snow Hill out of the equation there for the moment at least. Another cool little trick you can do with SkyVector is you can plot a point based on a radial and distance. So for example, if we were going to fly direct out of Norfolk to Cape Charles, and then we wanted to track on a 035, and it would kind of come up to the left of this blue line here that represents the 041, that's a Victor Airway. But say, look, about 035 comes right through here, and it looks like it comes up maybe parallel to that border. Let's say CCV 035, you put in 3 digits for the radial and then 3 digits for the distance. Let's say 035 and what about 50 miles? See what that put. Yeah, so that kind of nailed it actually. So yeah, a 035 tracked out to 50 miles would put you kind of almost right up the middle here, maybe a little closer to the east side than the west side of that that tunnel. But that distance puts you right over top of the corner where that restricted airspace turns in, and then from that point, 50 miles northeast of Cape Charles, you can kind of turn direct to Ocean City. You pass right over the town of Snow Hill here, and you're well outside of the restricted airspace. You're well outside of the Salisbury class Delta, the controlled space around that little airport up there. If you got to this point and you weren't quite sure, you couldn't spot Ocean City, you turned to that 070-ish heading, and you still didn't quite see the airport. Here's another little trick you can put in. You can put in this NDB called Landy into your ADF. It's frequency 407, and the identifier is OX. We can put that right into the flight plan, and so then you can use your ADF arrow after you stop tracking this 035 out. Use the ADF to track over here towards the Ocean City Airport, and it would put you on basically essentially a 5-mile right base for runway 14, which is where that NDB is. Although that's not how we're going to make the pattern entry. We'll talk about that later in the tutorial about how we'll make the pattern entry when we get there. But you can at least use that that NDB as a means of getting some guidance if you weren't quite visually able to spot the airport from down here where you're just getting to the end of that 50-mile leg off of Cape Charles. Now, real quick, let's talk about this Salisbury Airport and this Class Delta airspace. It's not terrible, per se, if you were to pass over that airspace or enter it or whatever. It just means that you would have to be in contact with the tower controller there at Salisbury, or on VATSIM, the approach or center controller that was covering that overlying airspace that would be handling tower duties there at Salisbury. My feeling, though, is in a flight like this, where you're going to be doing most of it outside of controlled airspace, with the exception of right down here around Norfolk when we depart, but for the rest of this path takes us very much away from any other controlled airspace, and there's no real reason to be overflying Salisbury when we can stay well outside into the Class Echo airspace and not be anywhere that we would need to talk to a controller. And I just feel like unless you're doing like a Bravo transition where you need to be talking to the Class Bravo approach controllers, it's just best to avoid Charlie and Delta when you can, because it limits the possibility that you're going to wander into their airspace accidentally without talking to the right controller first. Alright, now all that being said, here's the third way you can do it. And let's blank this out one more time. Whoop, I didn't mean to. Let's put the KORF and KOXB. I meant to blank the route out, not the origin and destination. But anyway, the third way, and really by all rights, this should probably be the first way, the primary way. This is, after all, called VFR, and we're doing it visually, and that's what the V stands for, right? I jokingly call it vaguely following a route. But honestly, the best way to follow this path, VFR, is to look out the window. Now, granted, this works better in some simulators than others, but in this case, we've got a really, really easily identifiable landmark to spot. And that landmark is the land. The land is the landmark. So let's do this. We can drag this path over, and of course, this first point really kind of ends up right there at Cape Charles. We can hit that, even though we, in this case, would not be navigating to that VOR, we would be navigating to the coast. But you can do this all the way up. You can drag the path over, and you can choose the bottom one, which is a GPS point. So it's just going to put a waypoint there based on the latitude and longitude. And you add a few of these to kind of approximate the coastline all the way up here. And then you get to this point. This should be this here, at least in my estimation. Let's just draw this so I can highlight it for you. I would say this shape of this coastline here, that should be pretty readily identifiable, even if you're in an older sim that doesn't have as detailed scenery. That should be something that you could pretty easily spot. So everything from the departure up to this point should be fairly obvious. And then from this point in the shoreline, what's it, about a 0.63 and 34 miles? Well, what you can do actually, and SkyVector's great with this, you can just keep adding visual reporting points. Let's use the town of Pocomoke City there. So it'd be a 0.53 and 9 miles to Pocomoke. And then another one up, you can kind of follow the 113 highway here, and then there's the town of Snow Hill. And each point that you add, SkyVector will tell you what heading to fly, what course to fly, and how much mileage is left for your destination. So this is a real easy tool that you can use to kind of plot your path as you go. And SkyVector will kind of keep track of what heading you need to fly from there to get to your destination and how much distance is remaining. Essentially, you end up doing a combination of visual landmark navigation and dead reckoning, which is flying by a heading indicator and a stopwatch, really. And that's something that you can kind of lean on as a backup plan in case the visuals in your scenery aren't that good. And really, honestly, most of my VFR flying is a combination of flying by visual reference with equal parts dead reckoning and radio navigation as backups. So when I fly this, I'll do it mostly by the coastline, but you can bet that I'll probably have this Snow Hill VOR tuned in as a backup plan, just as a reference point for when I pass Pocomoke City and Snow Hill, and especially to give me a good distance reference to the destination, which we'll talk about in just a moment. And you can probably bet that I'll have this NDB tuned in as well, just as a complete fail-safe in case I get up in the area here and I can't seem to spot the airport. That arrow will point me mostly in the right direction. Now, we'll get all the way up here, and now let's talk about what happens when we arrive. You can see that the airport icon here is magenta, which means that there's no control tower. On VATSIM, that means that we'll be on 122.8 for our CTAF calls, Common Traffic Advisory Frequency. You can see right here that the real world uses 123.05 for CTAF at OXB. VATSIM allegedly will one day do the same, but for now, we're always on 122.8 when we're not in controlled space on VATSIM. You want to start making these pattern entry calls when you're about 10 miles out, which is kind of here-ish, maybe. We'll see. And let's get rid of that point. Can we delete that? Come on. Delete. There we are. So yeah, okay, that's 9. But basically in this area, that's a little bit north of the town of Snow Hill and kind of where Chincoteague Bay starts to really get narrow there. Now you can also see that there's no indication of right pattern here. If there was any of these runways where the standard traffic pattern was a right pattern, you'd see it right here. Let's kind of just crudely draw in what that would look like. It just might say like RP14 or RP32 or whatever. Maybe both. You'd probably see 1.4 and 3.2, but you know what I mean. But we don't see that there, so that means all of these runways are left traffic. So what does that mean for us? Well, actually, we kind of need to know what runways we have here. That'd be a good thing to know. You can click on the airport and it'll give you some information. I kind of just prefer to do, just pull up. There's no airport diagram, but we've got this VOR alpha, and there's a little mini diagram down at the bottom. We can kind of use that and give us an idea of what the runway configuration is here at OXB. And we've got a 2 and 20, and then we've got a 1, 4, and 3, 2 here. So given that these are all left patterns, the entry that we're going to make coming from the south or southwest is going to depend on what runway the winds are favoring and what runway we want to use for our arrival. So kind of the easiest case coming from this direction is if we're landing on runway 20, we'd have to kind of just come in from the southeast a little bit and then almost line up like we're going a straight in on 3-2 and then join midfield downwind and then left turn to base and left turn to final for 20. So that's kind of the easiest case. I guess a second easiest case might be if we're landing 3-2, we would need to kind of just come over to the west and come in from the west side of the airport, come straight in this way, and kind of when we get to this point where we're pointed at midfield, we make our right turn, we go downwind for our, kind of on our 140, and then we turn left to the base heading and left to 3-2. Third case would be landing runway 2. You'd be tempted to just want to do a straight in, but in order to do a traffic pattern at an uncontrolled field, you really do want to do a full pattern so that you're not cutting off somebody who's already in the pattern. And of course, on VATSIM, there's not going to be that many people in the pattern at Ocean City Municipal on a given day. But just to kind of do things the right way, you don't want to just make a straight into a non-towered field normally. But in this case, you want to kind of work your way to the west. You almost want to go out to where that NDB is, that Landy NDB. It's 5 miles out to the north and west, and come in from that way. Again, kind of lined up like you're straight in for 1-4. Then you make the right to the downwind to runway 2, the left base, and then the left turn to final, landing on runway 2. The most complicated case, therefore, is 1-4. If we're landing 1-4, the standard kind of recommended entry where you have to cross over the field to get on the correct side for the downwind. The older way is what I've depicted here at 500 feet above traffic pattern altitude. And we assume, since the field elevation here is 11 feet, we assume traffic pattern altitude is essentially 1,000 feet. It's 1,011 to be completely technically accurate, but we'll just say 1,000 feet round figures. So at 500 feet above traffic pattern altitude, or 1,500, we come in from the southwest, which is good because that's the direction we're already approaching from. We'll overfly midfield. We'll count, probably about 30 to 45 seconds to make sure we get out at least the distance of this base leg here. Probably maybe go an extra 30 seconds or so. Then we start this nice big sweeping right turn and descending to the traffic pattern altitude to join that 45 coming in from due east. And we should, if we set it up properly, we should end up pointed right toward midfield to join that midfield downwind. And there we are kind of on a 3-2 heading there. And then we make the left turn to base and left turn to final on 1-4. Now, just recently, it's become acceptable to not have to do that big teardrop turn. You can kind of do this direct turn onto downwind from your midfield overflight. So you want to overfly 500. As you make this left turn, go ahead and descend into the pattern. Again, scanning very aggressively to make sure that there's nobody already on that downwind. But then you can go ahead and do kind of a direct join to that downwind, left base, left final. I'm old school. I always do things the old school way. So I like making that big sweeping turn, coming in off that 45, and I think that gives you, in my opinion, better visibility along that downwind to when you're merging. It's almost like an exit ramp. You're kind of merging in, doing the cloverleaf exit ramp and merging into that downwind. So I don't know. I think that gives you better visibility of the traffic that might already be in the pattern. But again, I'm not a real world pilot, so I don't really have a true perspective on that. One last thing before we go to cover the bases, let's just say we were going to decide to change the plan up and land at Salisbury or land at some other towered field, or maybe even you're using this tutorial to help you plan your own flight where you're landing at a towered field. And let's assume, for the sake of the discussion, that there is VATSIM staffing at that position, or covering that position via top-down. So there's an approach controller that overlies that airspace, or there's a center controller that overlies that airspace that's handling the tower duties there. Difference number one is that instead of starting with these CTAF calls 10 miles out, you're going to be calling the tower controller 10 miles out. In the case of a delta like Salisbury, so the ring is 4, and I'm told that the VOR ring is actually where the 10-mile threshold is, so that kind of makes that one really easy to depict. But it's some other delta, like maybe if you're up here, well, that's an Air Force base. Maybe if you're over here at Easton, you don't have a VOR there, but you can kind of judge if the ring is, if the delta ring is 4 miles out, then you basically go, another 4, and then here. So basically, kind of out to where word Concord is, I would guess. I'm not going to mess up my whole plan here to measure that, but I'm going to guess that's about 10 miles. Now, in the case of a Charlie, like down here at Norfolk, you're actually contacting the approach controller 20 miles out. Matter of fact, it says so right on the chart, contact Norfolk approach within 20 miles. So the ring, the Charlie ring goes 10 miles out, so you can add another 10 onto that, and that's where you should be contacting the approach controller at a Charlie. And then in a Bravo, you're contacting probably about 10 miles before you enter a Bravo. Up here we go, the Potomac Bravo. You want to contact the approach controller for the Bravo at least 10 miles before you get to that border and get permission, actually an explicit clearance to enter that Bravo. So when you're talking to a controller, you don't really need to worry about that midfield overflight. Let's go back to that picture. You're not going to really be given something crazy like this. Usually the controller would give you a pattern entry for a left or right downwinder base based on whatever makes the most sense given the direction that you're approaching from. So like in an alternate universe where OXB has a control tower, you're approaching from the southwest and landing 14, they might say enter a right downwind for runway 14, and you can kind of do that. Or if you're further out, they might even say enter an extended right base for 14, and just have you come in basically right like that. So in this case, as you're proceeding northeast toward the airport, you kind of just stay to the left, and then just as you come up on that extended center line, turn into your final. Point is that ATC gives you the pattern entry, and then it's basically just assume from there that you know when to turn to follow the rest of that pattern to the runway. We'll cover the communications aspect in another tutorial. I don't want to get too deep into that right now. But basically, that wraps up the topic of VFR route planning and navigation. There's a lot more that I didn't cover here, so feel free to ask questions in the comments. And if I find that there's a lot left unanswered, it might merit like a part 2 tutorial for this at some point. But I'm hoping that this, at least, will be enough to get you through maybe the first 1 or 2 VFR VATSIM flights. We'll see you live on Twitch TV, and in the meantime, travel safely in your own adventures. Take care.